Hey guys! Welcome back to my channel. If you like my videos, please like and subscribe. Today we're going to be learning about compound inequalities. Let's get started. So compound inequalities are two separate inequalities that are joined together. So let's say that we have these two inequalities. So to turn this into a compound inequality, we would have to take both of these inequalities and join them together. And then to connect them both together, we would connect it with either the word and or the word or. So our compound inequalities could either be x is greater than 5 and x is less than or equal to 9, or it could be x is greater than 5 or x is less than or equal to 9. Now that we've talked about what compound inequalities are and how they are connected, let's move on to the next part to figure out what and inequalities are. So when you write and inequalities, you want to find the solution. And the solution of an and inequality is the intersection of the two separate inequalities on a number line. So basically, wherever both of the inequalities connect, that's going to be where your solution is. And if the inequalities don't connect at any point, that means it's going to be an empty set or it's going to have no solution. So if I have this and inequality right here, and my inequality says x is greater than 5 and x is less than or equal to 9. So to find the solution set to this, what we're going to want to do is graph it. So I have this number line right here, and I'm going to use this number line to graph it. So for these inequalities, we're going to graph both of these separately. So if you remember, the first step to graphing an inequality is whether you're going to use an open or a closed circle at that number that they've given you. So this one says that x is greater than 5, and so greater than 5 doesn't have that bar down there that says greater than or equal to. So since it doesn't say that, we can say that this will be an open circle. And since x is greater than 5, that means all solutions to this inequality are going to be greater than 5. So everything is going to be shaded to the right of the number line. Over here we have x is less than or equal to 9. Since it has that equal to part over there, we can say that this is going to be a closed circle. And since all of the solutions are less than or equal to 9, that means everything is going to be shaded to the left on the number line for this inequality. So if I go on to graph it, let's say we have a 5 right here and we have 9 right here. We're going to graph our first inequality first that says x is greater than 5. So down here it says that we're going to use an open circle at 5 and that everything to the right of 5 is going to be shaded. So I'm going to shade in everything to the right of 5. And I'm going to have the little arrow right there to symbolize that it keeps on going. Now for the next inequality, we said that we're going to have a closed circle at 9, and everything to the left of 9 is going to be shaded in. So I'm going to shade in everything to the left of 9, and I'm going to have those little arrows there again to signify that everything goes to the left. Now, if you look at our number line, everything on the number line to the right and to the left is shaded. But that doesn't mean that our answer is all real numbers, because as the and inequality states, the only valid solutions are the parts where both of these solutions are intersecting, so where both of the solutions are. So if you look over here, 5 is not part of the solution, but you can see the intersection over here. So the intersection is everything greater than 5 all the way up to 9. Right there, that is our intersection, the purple part. So for this inequality, this graph would state our solution. And so when we write out our solution, it's going to end up saying that 5 is less than x, which is less than or equal to 9. So then this right here is our solution. 5 is less than x, which is less than or equal to 9. And this inequality here states exactly what the purple section has, that the 5 is not included in the solution, but the 9 is, and also everything in between. So everything greater than 5 and everything less than or equal to 9 is part of the solution. So that's what that states. Let's move on to the next one and see what OR inequalities are. So for OR inequalities, the solutions are the solution of either inequality, but both of them are still graphed. So let's say we have this inequality right here, and I want to graph the solutions of this inequality. So to graph this, the first thing we're going to do is see if it's an open or a closed circle. So for this one, x is greater than 9. It doesn't have the greater than or equal to symbol, so we're going to say it's an open circle. And since x is greater than 9, everything to the right is going to be considered a solution. So it's going to be pointing to the right. Over here, it says x is less than or equal to 5. So for this one, since it has the less than or equal to symbol, we're going to say that it's a closed circle. And since all solutions of this inequality are less than or equal to 5, we're going to shade everything that's to the left. So now we're going to bring these onto the number line. And so we're going to have 5 about right here, and then 9 about right here. And we're going to graph these. So the first one we're going to graph is x is greater than 9. So we see there's an open circle at 9, and then everything to the right of 9 is shaded. And then we have that arrow there indicating that everything to the right is shaded. For the next one, we have x is less than or equal to 5, and it says that we have a closed circle at 5. And everything to the left of 5 is supposed to be shaded. So I'm gonna shade in everything that's to the left of the 5. And we're going to have that arrow there that signifies that everything going to the left of that is still shaded. Now that both of these are shaded, if you look, there is no intersecting part. But the OR inequality says that the solution of either inequalities are valid. So it means that nothing really has to overlap. So the solution of x is greater than 9 would be a valid solution, and the solution of x is less than or equal to 5 would also be a valid solution. So our solution would end up being the same thing above, which was x is greater than 9 or x is less than or equal to 5. So that's our final solution. Now that we've looked at both and OR inequalities, let's move on to the next page and do some practice problems. So for our practice problems, let's look at problem number 1. Problem number 1 says fill out the table. So on the right we have our OR inequalities. So on the left we're going to have our AND inequalities. So for AND inequalities, the intersection of both of the graphs is the solution. But for OR inequalities, we can look at either of the graphs for the solution. So for OR compound inequalities, we look at both of the graphs of the two separate inequalities and we just take all of it as the solution. But for AND compound inequalities, we only look at the shared portion of both of the graphed inequalities for the solution. Now that we filled out our table, let's move on to problem number 2. So problem number 2 says to solve and graph the following AND inequalities. So if I look over here at this first one, there's nothing really to solve, so all we have to do is graph this. So I'm going to draw this tiny little number line right here, and we're going to graph it on here. So remember, the first thing we want to do is figure out if it's going to use an open or a closed circle. So if we look at our first one over here, it says x is less than 16, and since it doesn't have that less than or equal to part, we can say that this one's going to be an open circle. And since it says that all of the solutions for that inequality are less than 16, our arrow is going to be pointing to the left. Now for this one, we have x is less than or equal to 4. So less than or equal to indicates that we're going to have a closed circle. And since all of the solutions for this one are greater than 4, our arrow is going to be pointing to the right. So let's take this to the graph now. And let's say that 4 is located about right here and 16 is located right here. So we're going to graph the 16 one first. So it says that we have an open circle at 16 and that we are shading everything to the left of that open circle. And we're going to have that arrow there that indicates everything shades all the way to the left. Now for our 4 one, it says that we have a closed circle on 4. I'm going to draw that closed circle on 4. And it says that we need to shade everything to the right of the 4. So I'm going to come here and I'm going to shade everything to the right of that portion. And I'm going to have that little arrow right there. Now remember, for and inequalities, the solution is the intersection of both of the graphs. So if we look at the intersection, it is this portion right here in purple. So that point right there is our intersection. And so if we look at here and we try to figure out what the solution is as an inequality, we can see that 4 is part of the solution, and then everything greater than 4 but less than 16 is also part of the solution. So to write this as an inequality, we can say that 4 is less than or equal to, since 4 is part of the solution, x, which is less than 16, and less than because 16 is not part of the solution. So this right here would be our answer for this one. Let's move on to the next problem. Our next one says 3x is greater than or equal to 18 and x is less than or equal to -4. So for this one, we actually do have to solve for this one because we want to have x alone on one side, and this first inequality doesn't have x completely alone on one side. So I'm going to solve for x for this first inequality. I'm going to divide both sides by 3. And I'm going to get 3x over 3 gives me just x, which is going to be greater than or equal to 18 over 3, which is 6. And so my new compound inequality is going to end up being x is greater than or equal to 6 and x is less than or equal to -4. And so now we're going to graph this new compound inequality. So let's say I have my number line again right here, and I'm going to graph it on here. And so first things first, we're going to see if it's open or closed circle. So our first inequality is x is greater than or equal to 6. Since it has the greater than or equal to part in it, we're going to say that this is a closed circle. And since all solutions of x are greater than or equal to 6, our arrow is going to be pointing to the right. For x is less than or equal to -4, since it has the less than or equal to part in it, we're going to say that it's a closed circle. And since all solutions of x are less than -4, our arrow is going to be pointed to the left. So now let's graph this. So let's say we have -4 at this point right here, and we have 6 at this point right here. So we're going to graph x is greater than 6 first, and so we said that we have a closed circle at 6, and our arrow is pointing to the right. So we're going to shade in everything to the right of this. For our second one, we have x is less than or equal to -4, and we said we have a closed circle on -4, and our arrow is pointing to the left. So we're going to shade in everything to the left of -4. So now that we have this graphed, we want to see where these two graphs intersect to find our solution. But as you see here, there are no intersection points. So the two graphs of these don't intersect anywhere. So that means that there is no solution to this inequality. So when something like this happens, we call it an empty set. So the solution to this would be nothing. It would be an empty set. And there's also a symbol that we could write, which would be like a 0 with a slash through it. So this is our answer right here. On the next one, if you see, there is no mention of the word and anywhere in this inequality. So this inequality says -16 is less than x plus 3, which is less than 75. Even though there is no mention of an and anywhere in here, this is still considered an and inequality. So whenever you see a compound inequality that is formatted like this, it's never going to be an or inequality. It's always going to be an and inequality. So over here, we can't graph this inequality just yet. What we have to do first is we have to get this x alone in the middle. So if you see here, we have an x plus 3 right there. So we want to get rid of that plus 3 and we just want x completely alone in the middle. So the way to do this is to get this x alone, we have to use inverse operations and we have to subtract 3 to get the x only alone. So when I subtract 3 from this middle part right here, I also subtract 3 from the right part over here, and I subtract 3 to the left part over here. So whatever I do to one part of this compound inequality, the same thing will be done to the other two parts. So since I subtracted 3 from the middle part, I also had to subtract 3 from the right and from the left part. And so if I solve this, I'm going to get negative 16 minus 3, which is negative 19, which is less than x plus 3 minus 3, and that gives us just x, which is going to be less than 75 minus 3, which is 72. And so this right here is going to be the inequality that I graph on my number line. So let's say I have my number line right here, and I want to graph this compound inequality. So the two sides of this compound inequality is negative 19 on the left side and 72 on the right side. So I'm going to have negative 19 right here, and I'm going to have 72 over here. And what this compound inequality is telling me is that the solutions of x are in between negative 19 and 72. But since we don't have this less than or equal to sign underneath any of them, that tells us that negative 19 or 72 are not actually part of the solution, just everything in between it is. So when we have that less than symbol without the equal to part in it, we know that we have an open circle on those areas. So we're going to have an open circle at negative 19 and at 72. And since everything in between there is a solution, we're going to shade in everything between 19 and 72 as our solution. So for our final answer, we're just going to end up with the same equality we had up there, which was negative 19 is less than x, which is less than 72. And so that is going to be our final answer. Now that we have this done, let's move on to problem number 3. Problem number 3 says to solve and graph the following or inequalities. So if we look at our first one, our x's are completely alone, which shows us that we don't really have anything to solve for. So we're going to get on with graphing it on the number line. So if I look at the first inequality, it says x is less than 16. So the less than indicates that it's an open circle. And since all of the solutions of x are less than 16, our arrow is going to be pointed to the left. For x is less than or equal to 4, since it says less than or equal to, it indicates a closed circle. And since all of the solutions of x are less than or equal to 4, our arrow is also going to be pointed to the left. And so if I look over here to start graphing this, I'm going to put 4 right here, and I'm going to put 16 right here. And so first I'm going to graph the first one, which says that x is less than 16. So I'm going to graph the first one where we said that we're going to have an open circle on 16, and that everything to the left of that would be shaded in. Our next one is x is less than or equal to 4. And we said we're going to have a closed circle on 4. And we're going to shade in everything to the left of the 4. So if we remember back what we said about the OR inequalities, it was that when we graph it, we look at both graphs and we take the solutions of both of the graphs. So if you look over here, the solution set of x is less than or equal to 4 falls inside of the solution set of x is less than 16. So if you wanted to find the solution set of this compound inequality right here, all we would have to do is take the solution set of x is less than 16, since the other inequality, x is less than or equal to 4, falls within that inequality. So our solution for this one would be x is less than 16, and that's it. That's our solution. So over here, this problem has the exact same inequalities as the one above. The only difference is that this one says OR instead of AND. So if you look over here again, you can see that we have the unsolved inequality on the left over here. And when we solved it up there, remember we got x is greater than or equal to 6. So for our compound inequality, we're going to write x is greater than or equal to 6, or that x is less than or equal to -4. So this is going to be the inequality that I graph. So let's have our number line right here, and let's figure out if we're using a closed or open circle. And so this one says x is greater than or equal to 6, and the greater than or equal to symbolizes a closed circle. And all of my solutions are going to be greater than or equal to 6. So our arrow is going to be pointed to the right. For this one, we have x is less than or equal to -4. And so less than or equal to indicates a closed circle. And all the solutions are less than or equal to -4. So our arrow is going to be pointing to the left. Now to graph this, I'm going to keep -4 right here, and I'm going to have 6 right here. And I'm going to graph both of these. So remember, for solutions of OR compound inequalities, we just look at both graphs and we take the solutions of both of them. And so if we take the solutions of both of them, we're going to end up with the same inequality that we had up here. X is greater than or equal to 6, or x is less than or equal to -4. So that's going to be my final answer. So for our next one, we have x plus 3 is greater than -16, or x plus 3 is less than 75. So if we look at both of these, they're not completely solved because the x isn't on one side completely alone. So I'm going to finish solving these. So my final compound inequality is going to be x is greater than -19, or x is less than 72. So now we're going to graph this, and we're going to figure out if we use open or closed circles. So for our one on the left, it says x is greater than -19, and so that shows us that we're going to have an open circle, and since the solutions are greater than -19, our arrow is going to be pointed to the right. The second one says x is less than 72, and so since it says less than, we're going to have an open circle, and all of the solutions are less than 72, so our arrow is going to be pointed to the left. Now that we have this done, I'm going to label our number line, and I'm going to put -19, and I'm going to put 72 over here. Now I'm going to graph these on the number line. So now, when we solve OR compound inequalities, we look at both graphs and we take the solutions from both of them. So if we look at this graph right here, if you see, everything on this number line is shaded, which means that everything is part of the solution. So since the entire number line is shaded and it keeps on going forever, that means our final answer is going to be all possible values of x. Or it's going to be all real numbers, which we can signify by saying ARN, all real numbers. So just because everything has been shaded in, we can say that all real numbers is our final answer. So that's it for today, guys. For more videos like this, please like and subscribe, and be sure to comment down any topic ideas you have for me or any questions you have regarding this topic or any other topics. Also, be sure to follow me on Facebook and on Instagram. Thanks for watching. See you next time. Bye!